Hello everyone, my name is Bagus Mahaaditya. Today I will presenting about metallurgy, especially in heat treatment of non-ferrous alloy. Okay, we go to next slide. For the reference, I use book Metallurgy for the non-metallurgists, second edition, that edited by Arthur C. Tirta. Okay, here is several content I will explain about in this presentation, especially a content. The first one is recovery and recrystallization annealing. The second is heat treatable aluminum alloy. The third is cobalt alloy. The fourth is copper alloy. The fifth is magnesium alloy. The sixth is nickel alloy. The seventh is titanium alloy. The eighth is other non-ferrous alloy. Okay, let's begin the presentation. The first one is recovery and recrystallization annealing. So, annealing is a generic term used to denote a thermal treatment process that consists of heating the material to an end temperature and holding or soaking it for a sufficient length of time at that temperature, followed by cooling at a suitable rate. When annealing is performed for a short period of time or at a low temperature, the hardness of cold work alloy remains relatively constant. This initial stage is referred to as a recovery annealing. So here is a picture of state of annealing. The picture is the effect of annealing time at the fixed temperature on hardness of Cu5Zn solid solution alloy cold work at 60%. And for the picture is effect of annealing temperature at fixed time in 15 minutes on hardness of Cu5Zn solid solution alloy cold work. For the cold work is in 60%. Okay, we go to the next slide. Okay, the next slide. When the soak temperature is sufficient high, recrystallization can take place. During the stage of annealing, new strain, free grain nucleate and grow from the deformed grains of a cold work alloy. Okay, here's the picture about recrystallization temperature. The picture A is as a function of a degree deformation, and for the picture B is a melting temperature of metal. Okay, we go to the next slide. Heat treatable aluminum alloy. The difference of aluminum alloy also can be classified as either heat treatable or non-heat treatable. The highest strain level are attained by the heat treatable alloy. The non-heat treatable aluminum alloy is include the first one is aluminum. Is the first one is the pure aluminum. The second is aluminum manganese alloy. The third is aluminum silicon binary alloy. The fourth is aluminum manganese binary alloy. The last one is the other miscellaneous alloy. Work heat treatable aluminum alloy is include the aluminum copper series, the aluminum magnesium silicon series, the aluminum zinc series, and the aluminum lithium alloy of the series. The alloy exceeds the higher level of static tensile strength, but with less of an improvement in fatigue and endurance. Gas heat treatable aluminum alloy is include the aluminum copper, some of aluminum silicon plus copper and magnesium alloy, and the aluminum zinc alloy. And by the far, Most widely used for the aluminum casting alloy are the aluminum silicon alloy with magnesium or with copper. We will go to the next slide. The next slide is cobalt alloy. Cobalt is very useful in application that make us use of the magnetic properties, corrosion resistant, wear resistant, and strength at elevated temperature. Biomedical application is another important use. The initial biomedical application of cobalt-based alloy were in the dental field, and early evolution of this alloy so excellent wear resistant, corrosion resistant, biocompatibility, and mechanical properties when used in vivo orthopedic implants. Hardening mechanism for the cobalt alloy is involved the solid solution threatening, word hardening, or solution threatening and aging. Okay, we go to the next slide. Copper alloy. Copper can be hardened by the solid solution alloying and by the work hardening. The commonly used solid solution alloying element lists in approximate order of increasing effective are zinc, nickel, manganese, aluminum, tin, and silicon. There are two general types of heat treatment used to hardening the copper alloy. The first one is those that are solved by the high temperature quenching and the hardened by the low temperature precipitation heat treatment. The second is those that are hardened by quenching from the high temperature through magnetic type reaction. The quenching hardening alloy include the aluminum bronze, nickel aluminum bronze, and a few special copper zinc alloy. Quench hardening alloys are usually tempered in the manner similar to the used for alloy steel to improve the toughness, improve ductility, and reduce the hardness. Okay, we go to the next slide. Magnesium alloy. The basic temper of designation used to designate the various type of treatment for the magnesium alloy. The first one is fabricate. Sorry, the F is used for the fabricate. O is analog crystallization, crystallize. The O is analyte crystallize. The H is strength hardened. The W is solution heat treated. The T2 is analyte. T3 is solution heat treated and the T4 is solution heat treated. T5 is artificially egg only. T6 is solution heat treated and artificial age. The T7 is solution heat treated and stabilized. The H is the solution heat treated cold work and artificially aged. The T9 is solution heat treated, artificially aged, and the cold work. T10 is artificially aged and cold work. Heat treatment can improve the mechanical properties of magnesium casting alloy. In most wrought alloy is the maximum mechanical properties are developed through the strain hardening, and these alloy are generally used without the subsequent heat treatment or normally adds to the T5 temper. Okay, we go to the next slide. Nickel. Nickel alloy. Nickel is an austenite former and allotropic-based transformation that occur in nickel or the high nickel family of alloy. The alloy are austenite from the melting temperature down to the absolute zero. Nickel has a natural tendency to combine with sulfur sulfur, and oxygen, or it is found in nature as the nickel sulfide and nickel oxide. In the treating nickel or oil, it is critical to minimize exposure to the sulfur in fluid or lubricant grease or the gaseous form. Okay, here is the table for the some example of aging condition for the super alloy. We can pause the video if you want. Like alloy is a Monel K500, and here's the temperature, and here is the edge hardening. We can pause the video. Okay, we go to next slide. Titanium alloy. Titanium and titanium alloy are heat treated in order to reduce the residual stress developed during the fabrication, produce an optimum combination of ductility, machinability, and dimensional and structural stability, increasing strength, and the last one is the optimize the special properties such as the fracture toughness, fatigue strength, and the high temperature crack strength. The response of titanium and titanium alloy to heat treatment depend on the composition of the metal and the effect of alloying element on the base of transformation titanium. Titanium alpha alloy. Unlike the alpha min beta and the beta alloy, the alpha and near min alpha titanium is alloy cannot be shrunken by the heat treatment. And titanium alpha minus beta alloy are the most common and most versatile of three types of titanium alloy. A wide range of strength level and can be obtained in the alpha minus beta or the beta alloy by solution shortening and aging. And the last one is the titanium beta alloy. The principal final heat treatment for beta and near minus beta alloy consists of the aging of material previously in beta anode and water phase. Okay, we go to the next slide. Other non-ferrous metal alloy. Heat treatable silver alloy. The precious metal, including silver, behave somewhat similar to copper and nickel. The most important silver alloy are the silver gold type, the gold alloy, which find application in the jewelry or setting, trade, and in dentistry. Generally contain the silver and copper, and sometimes zinc, nickel, platinum, and palladium. Heat treatable low melting alloy. Zinc-based alloy cannot be improved in sufficiency by the heat treatment to warrant the commercial consideration of the such practice. Okay, we go to the next slide. Okay, here's the last slide in this presentation. Hope you enjoyed my video and give a like if you like my video, and you can subscribe. It's free. It's all yours. Okay, thank you for watching and see you in the next presentation. Bye bye.